others are joining. Okay. All right. No problem. No problem. I don't know. Am I clear? Am I clear? Because this side today, there's a lot of noise, so I don't know if I'm clear. Is it clear?
Yes, you are.
Yes,
Yes, we can hear you.
All right. No problem. I think this Zoom is helping us to reduce the background noise. It's fine. Then this one, I think, okay, if 1 kilometer is 5/8 of a mile, convert 75 miles to kilometers. Or what can we, how can we approach this one? We are given. There are so many ways that we can use in this case. We are simply saying in a kilometer, how many miles do we have? 5/8. 5/8, it's a fraction, it's a decimal, it's a, we can have it as a decimal. It's a common fraction on its own, but it can be written as a decimal fraction. 5/8 as a decimal gives us what? 5 into 8, that is gonna be 0, into 55. I mean,
I think it's
0.625.
0.8.
0.625.
625. Oh,
Yeah.
so meaning to say
Yes.
we've got 0.625 miles in this case. So what about 75 miles in this case? How many kilometers are we going to have? That is the question. So we can just use our simple proportion. Whether it's a fraction does not affect this one. 1 kilometer is equal to 7/8 of a mile. What about 75 miles in this case? What is going to be the corresponding value on this part? Still, it's one and the same thing. So that will be a more in this case. So we divide these two times a kilometer. 75 over 0.625 times what? A kilometer. Or we are going to have this as 75 over what? 75 over this, which is 7 over what? 7/8, which is times what? A kilometer in this case. All right, so that is what you're going to have at the end. So I don't know, but here we are going to multiply by 1,000 and you divide it digit by digit. It's gonna, because we've got 3 digits after the comma there, so you can consider multiplying by 1,000, and since we've got 3 digits after the comma, so you can multiply by 1,000 over 1,000 to remove this, so that will be 75,000. So we are going to have 75,000 over what? 625. So you can reduce digit by digit here. If you are dealing with a fraction on this nature, is this number divided to a fraction? Do not confuse with the previous part where I was saying if a fraction is dividing a term. This one is not a fraction dividing a term. It's a term, a single term dividing a fraction. So for you not to confuse, just apply your normal division, whereby if you are dividing, you introduce what? You introduce a multiplication, because this is same as 75 over 1 divided to this part, which is 7/8. So it means 75 over 1 times 8 over 7. I don't know if we are together, then we can reduce whatever part that we have. We can reduce these values. Are you having a common term here? Are we having a common term between 75 and 7? We do not have. So meaning we are going to have an endless decimal. Is that so? Or maybe there is a mistake. What are we going to have here? What was our solution on this one? If we are to reduce,
I hit 120 kilometers.
120 kilometers.
Yes, 120. Yes.
All right, then on this part here, 75 divided by this, is it the same? Is it gonna be the same?
No.
We are not
It's
having
going
the
to
same.
be 85,
Oh, it's a 5
Yeah,
here. So that's a 5. Where am I getting the 7? The 5, and sorry for that. This one is it's a 5. You see, 5 over 8 there. Because I'm now wondering, say, why are these values not reducing? So there is a 5 there. Sorry for that. So meaning to say we have a 5 here, and this one it's a 5. So meaning to say if we are working with a fraction, it was going to be easier, and 5. This one is a 5, so it's gonna be 8 over 5. So we can reduce here 5, 1, 5 here, it's gonna be 1, remainder 2, then 5 into 25 is 5, then you multiply 15 times 8, that's 40, 8 and 5, it's gonna be 40 there, 8 and this one plus, it's gonna be 120, which means we are supposed to obtain the same answer. So as you can see, we are working with a fraction. On the other part, we are working with a decimal, but still obtaining the same answer. Are we together? So that was the idea. I don't know if there's any other part. Then the bearing part here, the bearing of village P from Q, from, always consider the bearing from the village Q. That is where we are supposed to start. From Q is 109. What type of bearing that we are given? This one, it's a 3-figure bearing. We are talking about a 3-figure bearing in this case. Remember, for 3-figure bearing and compass bearing. Compass bearing is the one that you set in terms of north poles. It can be north 30 degrees to the east, or maybe it's south 40 degrees to the west. When you are presenting in this manner, that one we are referring to a compass bearing in this case. So this one is a 3-figure bearing, whereby you are just representing your values in terms of 3 digits. We do not have these poles. These were not this direction to the east or what. All right. So what is the concept of 3-figure bearing? Always is taken from the North Pole. Always, when dealing with the 3-figure bearing, is taken from what? Taken from the North Pole. Taken from the North Pole in a clockwise direction. So this one always is taken from the North Pole in a clockwise direction. I don't know if we are together in this case, in a clockwise direction. So meaning to say, whenever you see a question that has got 3-figure bearing, you take from the North Pole in a clockwise direction. So meaning here they are saying P from where? From Q. So we are supposed to consider this our North Pole at point Q. So this is our North Pole from Q. So this is going to be our Q in this case. The North Pole that we are having here, it's for Q. So you do not write the Q inside, just write Q aside that. So this is our point Q. So we are going to take this 109 from the north part, from the North Pole, going in the clockwise. So meaning to say we are supposed to maintain this direction. This is our clockwise movement. So by approximation, we can see 109, it's in between from 0 to 18, in between, because we've got 0, 90, 180. So after 90, but below or just before what? Before 180. So this is 0 from the North Pole. It means this is 0 here, this is 90, this is 180, this is 270, back to 360. Separated by 90, 90, 94. So 109 is going to be in between 90 and what? 180, just below 180, but after this value of 90 degrees. So this is where we are going to expect to have an angle of what? Of 109 degrees. I just hope we are together on this part. So that is from where? From Q. So meaning to say from Q, as we are moving from Q, where are we? Where are we to reach? We are going to reach the point P. From Q going to P. So P is the point. It's just an approximate. Maybe this is where we have our P. What's gonna happen with that P? We are going to indicate a north pole at that point P, because this is where we're going to have our P. So you can just indicate a north pole for the point P in this case. All right. So this is our north pole where we have our point what? Our point P in this case. So can you switch off your mic? Can you switch off your mic? You just turn it on if you are answering or responding to something. All right. So with the sketch that we are having, we can determine now whatever that you are given. So take note here. The question actually needs us to attempt. We need to the three-figure bearing and also the compass bearing. But now we are referring what? Q from P now, from P. All right, we say three-figure bearing is always taken from the north in a clockwise direction. So as we are considering now from what? From P, it means we are considering the north pole at P. We are considering the north pole. This is your P, this P. All right, so let me just try to write it closer so that I do not confuse you here. This north pole here is for P. So the direction that you are going to take if it is a three-figure bearing is always clockwise direction, but from its north pole. So we are supposed to move from P until we reach the line that is going to what? To Q, until we reach this one. So we are going to take from this like this one, going to Q. From where? From P to Q, from P from to this one. That is the idea. From P going back. So do not consider the first letter from. Where are we starting from? That is the idea. So the question is simply asking, calculate this angle, because three-figure bearing is the angle direct as it is, as long taken from the north pole. So the question is simply calculate this angle. So how are you going to calculate this angle? Forget about the bearing now. The bearing part, it helped us only to draw this part that we are seeing here. That is where bearing was playing a role. The calculation of this angle has nothing to do with the bearing. Go back to your geometry there, consider what we have about parallel lines, because these north poles, they are parallel, they do not meet. So we are now considering properties of parallel lines. It's no longer about bearing. We now have to consider our parallel lines. What is it that we understand from our parallel lines in terms of angles? So what can we do in this case? We can consider this angle of 109. Remember, from our parallel lines, if two lines are parallel, we have got the alternate angles, these ones that produce a Z, one that gives us a Z. These are alternate angles, and alternate angles are equal. You can also consider the alternate angle this way. These are alternate angles, these ones. They are also equal. So this one and this one, they are equal. So from the alternate angles concept, we can see that if this angle is 109, this angle also is going to be 109. This one is alternate to this one on this side here. It means also this angle is 109 degrees from this concept here, alternate angles, the one that create a Z. So it can be a stretched Z, like it cannot give us, it's not like we are supposed to see this Z as, it can be a Z which is stretched like this one that we see, just a Z, but that just stretched. So this one, if it is 109, this one is also 109. So to find the whole angle now, what are you going to do? You are considering now a straight line here. We've got angles on a straight line, which is from this point up to this point. We are considering angles on a straight line, which is what? 180 degrees. So the angles on a straight line plus this angle here gives us the complete angle that we want. Remember, we want to calculate this whole complete angle here is the one that we are supposed to calculate. I don't know, someone who is having an application that is controlling my screen this side. I don't know. Or if I don't know what is happening, but let's just hope it's not going to affect. All right, so here we need this whole angle here, which is the 180 of a straight line and the 109. So you're going to combine 180 degrees plus 109. That's the whole angle that we are considering in this case. So what are you going to obtain? Let us just add, it's gonna be 109, which is something like 289. All right, was this the only option? No. Was this the only option? What was the other way? What could be the other way to calculate this whole angle, this one that I'm indicating, this one in black, this one, from P to Q? We could have calculated this angle inside, the angle inside here, inside this angle here. From which concept? From our parallel lines, it follows that these two angles that are inside the parallel line, these two angles, they are co-interior angles. They add up to 180. These two angles, they add up to 180 degrees now. This angle and this angle, if this is A and if this is B, if you add these two, they must give us 180. The same with these angles that we are having on the other side, this one, they are also co-interior. If I add this angle here and this angle, I must obtain 180. So from the co-interior angle, you can see that this angle of 109 and this angle that I want to calculate inside, they are co-interior. So to find this angle here, I'm simply going to subtract 109 from 180 because they give us 180 if we add them. So I'm just simply going to subtract from what? From 180. So that's 180 minus 109 is what? 180 minus 109 is 171. Is that so? So we are going to obtain 71 in this case. But if this angle is 71 degrees, this one, if this angle is 71, what about this one? Because our question is not asking this angle, no. It is just helping us to calculate this angle from P, this whole angle that we indicated before this one. This is the one that we are supposed to calculate, this one in black, this one. So how are we going to calculate this angle now? We can consider to say angles at a point, a complete revolution, this one must give us what? 360 degrees. And out of the 360 degrees, I only have this part here. Out of the 360, the whole revolution that I was supposed to have, I'm only having what? 71. So what is the remaining angle? The remaining angle is simply going to be 360 degrees minus 71 degrees. We are supposed to obtain the same answer as the one that we have here of what? Of 289. So that is 3-figure bearing from the North Pole. You take it from the North Pole in a clockwise direction until you reach the line to where you are going to Q, from P going to Q, until you reach that line. That is the whole angle that you take. But when the question is asking you to calculate the compass bearing, take note on the compass bearing. That is one that I was saying. You are supposed now to work with the poles. Now, in our syllabus, actually, they consider the north, and so, but it's not supposed to be limited like that. Let me remove this part so that we can properly understand. I just want you to take note of these angles. Remember, here we've got 71, this angle here, and so forth. So I just want to take this part, retake this part here. So let us not forget our angle here, because here there was a lot of things to consider. So it's something like this, remember, that is our North Pole. and this is our P. And this angle we calculated, or we had this one of 289, whatever, but we know that this angle we have it was 71 degrees like this. Okay. So the whole idea about compass bearing, it's in within the poles that are creating the angle. I mean, this part here, we are saying is the bearing of Q from P. The idea is not changing. From P, yes, we are from the point P, but you are supposed to consider which poles are being affected now, because you are supposed to name the direction. Is it from the north to the east? Is it from the north to the west? So you consider where this line is affecting here. It's affect this line from this one, this line that we constructed from Q in the first place. Where is it reaching? Sometimes we can have maybe your sketch from another point, whatever that you have, then the line is passing like this. So what I'm simply saying is that you are supposed to consider the poles now that are being affected by this line. Where is it reaching? It is affecting the south and affecting the what? The west. So these are the ones that you consider. Where is it? Is it within the west and the south? Or maybe the line is in within this side here. That is where the line is entering. You work with that part alone. So in our syllabus, it's always best for you to consider from the south to the other, now to the minor poles, which is either to the west, or you're going to the what? To the east. Or maybe it's in this region. From this region, which poles are we supposed to work with? If your line was here, which poles are we supposed to deal with? We are dealing with which poles now? The north and what? The east. So meaning to say we are taking from the north to the east. If you are dealing with a line in this region, you are dealing with the north going to the what? To the west. So here you're going to have north, a certain angle, this angle going to the west, to the east, because this is our north, this is our east, remember our south, and this is our west. So it means the angle that is in this region, if your line is in this region, it is going to be north, a certain angle. We do not know this angle in degrees. But going to the what? To the east, we are moving from north to the east. If it was on this side, it's going to be from the north going to the west. So it's going to be north, a certain angle that is there to the west. In this quadrant, you move from the south going to the what? To the east. So it's going to be south, a certain angle that is affected there to the east. This one is going to be south, a certain angle in degrees going to the west. So what you need is to know the angle that is affected in those quadrants. So here we are saying from P here going to Q, our line is affected in within the which pole? It's affected this line. Where is it entering to P? Where is it entering? It's entering where there is the north and where there is what? The west. These are the only poles that you're supposed to focus with. Here there is not, this line is not here. We do not have anything. So you're asking yourself, if it is here, what is the direction now? From the north going where? To the west now, because we said if it is in this quadrant, it is going to be north, a certain angle. This is your direction, the angle, going to the west. So meaning to say our answer for the compass bearing was going to be what? The answer for our compass bearing was going to be north. How many degrees going to the west? We are moving from north 71 degrees. The angle that is in between the north and this line, it's 71 degrees.
Yes.
Going to the what? Going to the west. Are we seeing the idea of the compass bearing? Always north this direction, south this direction. That is what you're going to have. If you wanted to use this one, it's going to be complicated, but it's fine. You can take it from this way to say, yeah, what if I'm taking, because it's affecting the west and what? The north. So someone might ask to say, what if I take it from here? It's still the fine to say, what if you consider here, from west going to the north, as long you are giving the exact angle, say, I can move from west going to the north. This is the direction that you are choosing. But be careful now because you do not have this angle here. So how are you going to have this angle? You are now considering this is 90 degrees. So out of 90 degrees, I'm going to subtract 90 minus 71. So if we subtract 90 minus 71, this is going to be 19 degrees. So meaning to say I can rewrite the same answer that is representing north 71 degrees to the west as from the west going where? To the north. But which angle am I going to use? I'm going to use this one between the west going to the north, which is 19 degrees to the north. We could have answered in this way. What is important is labeling your information properly. So in our syllabus, and also for exam purposes, it is best for you to use always the north or the south, and avoid starting with the minor poles like working with the east or the west. It's fine, it's actually mathematical, but our syllabus is still having a lot of issues there. So it's best for you to just maintain whatever way they want you to answer these typical questions. So you see that if it was a consideration that sometimes you are given it as a three-figure bearing, as a compass bearing to sketch the diagram. You're also supposed to consider the same way, like for example, if we're given the compass bearing of A from B, we are given the compass bearing of A from B, which is in this case maybe south 30 degrees to the east. That is the compass bearing of what? The compass bearing of A from B is. Then from this bearing that we are given, now we are asked to find or to calculate now, find the first one. They will need maybe the compass bearing. All right, can you just turn off your mic? All right, so they will need us to calculate maybe the compass bearing, in this case of the opposite now, which is from what this time? The compass bearing of B from A. B from A, and the three-figure bearing in this case, three-figure bearing. All right, so you can have a three-figure bearing, that's it. Three-figure bearing of what? Of the same B from where? From A. We can be given information from compass bearing. What is important is the information that you are given. How are you going to relate? Three-figure bearing is the one that you take from the north in a clockwise direction. Compass bearing, you take the information from the poles that you are given. Yeah. Okay, what is important, like I said, is to have a sketch, but our sketch is always taken from B. So it means from B, we are going to have our north pole here. We are going to have the north pole here. This is our north pole, which is at what? From B, meaning to say this is where we have our point B. B is situated along this pole. So from this point B, we are supposed to go back to the A with this bearing. But what are we given this time? It's no longer a three-figure bearing that we're given before, to say the the bearing of this 109, where you are not given the poles. This one is a three-figure bearing. Now you are given compass, so we go back now to these compasses. I said it can be within the north and the east, the north and the west, the south and the west, or the south and the east. These are the poles. You are not going to have south, north, or north, south. We are not going to have something like that. And also the angle is supposed to be within this part, not to exceed. You are not going to have something like north 100 degrees to the east. It's impossible, because within the north and the east, you are supposed to be having an angle that is less than 90 degrees. So always the angle that you are supposed to have in between the poles here is supposed to be less than 90 degrees, because in between these poles, there's a 90 degrees. So you locate where the pole is supposed to be. So let us locate here. where are we going to have the pole? Just because of our time here, because I wanted us to talk before we finish up this part. So if we check here, south and east. So this is our north, south, east, west in this case. So we are moving from south to the east because south to the east, a certain angle of that. So meaning to say this angle is in between. As we are moving to the east, we are just going to move 30 degrees this direction, but we are not supposed to exceed the east because we are limited to the east. That is the idea, but the direction it's south to the east. All right, sorry for that. I think it's about the end of this meeting. Okay, it's fine. So I was saying the direction here is very, very important. Where you are going, the direction. So as we can assume, 30 degrees might be somewhere here. So this is somewhere there. From the south going to the what? To the east. From south to the east. That is the idea, the 30 degrees. So we can just assume somewhere here. Not from the north. It's different from the previous part where you are supposed to be always taking north in a clockwise. It would be for a 3-figure bearing. For a compass bearing, there's nothing like that. Compass bearing, you deal with the poles that you are given. Is it south to east, south to north, north to east? All right. So meaning to say from this part of from that it's always always from. You are supposed to work from. You are supposed to work with that from, and whether it's 3-figure bearing or it's compass bearing, always it's from. So we are from B to where? To A. So meaning to say this line is going to A. So where we are going to reach this point, we just indicate the north pole for what? For A. We are going to indicate now the north pole for what? For A. So this is the north pole for what? For A. So you can just write A aside, not on that point, just aside is fine. So the diagram now is the one that is going to help us to find the compass. The question is saying, find or determine the compass bearing of B from A. We are now focusing from this pole. This is the pole that we are focusing on from A. So from A going to B, compass bearing, I said, consider the poles. This line here, which poles is it affecting? This line. It's affecting which pole? It's affecting the pole of what? North and what? And the west. That is where this pole is affecting. So we need now the angle in between these poles. From the north as we are going to the west, what is the angle in between? Remember, in this quadrant, it's north, the angle to the west. So what will be this angle now? Calculating, who can help us to calculate this angle? What is going to be the angle, this one? Which idea can we take here? Remember, I said these lines, they are what? They are parallel. So if they are parallel, what does it mean here? We are going to create a zeta. Are we seeing that is what is happening here? We are creating a z. So these are alternate angles. So it's alternate to what? To this 30 degrees. If this angle is 30, this angle is also 30 degrees. So therefore, our compass bearing in this case is going to be north 30 degrees to the what? To the west. From north, moving 30 degrees going to the west. So that is going to be the idea there. Compass bearing. But for 3-figure bearing now, the item 2, 3-figure bearing of B from A. We said the 3-figure bearing always is taken from where? From the north pole in a clockwise direction. It's a fixed thing that you are supposed to understand on these two bearings. 3-figure bearing always, we are going to take this bearing from the north pole this time of A. We are from what? From A. So from the north pole of A in the clockwise direction until we reach the line that is going to where? To B. Until we reach this line, then we are done. We stop after reaching the line. If the line is somewhere like this is where you have your line, you do not continue to draw and say I'm supposed to just until you reach from the north until you reach the line. If the line is here, you end there. If the line was in this quadrant, meaning to say from the north pole in a clockwise until you reach that line, you end there. You focus now on that angle. You are now focusing on this angle now. How are we going to calculate the whole of this angle? Whether from this 30, as we indicated that if this angle is 30, this angle also is going to be 30. So angles on a complete revolution should give us 360. So this one, we are simply going to subtract 360 minus what? 360 minus 30. So the moment we subtract this 30 degrees, we remain with what? 330 degrees. So that is going to be 3-figure bearing. It's here supposed to have 3 digits. Mostly if you're given a quadrant, if it is in this first one like this, you obtain an angle that is less than 90 there. You're going to obtain, a 2-digit value. You're going, maybe it's 60 degrees. On your final answer, you write it as 060. 3-figure, 3 digits, 3-figure. If your answer is 60, you write as 060. If your answer is 30, 030, you add a 0 so that you now have what? 3 digits. That's why we are called 3-figure. But the idea is always from the north in a clockwise direction, from the north in a clockwise direction. All right, so that is the idea there. So just because of our time, it was actually a clash program that we had with others that we're supposed to have our normal class. So what we are going to do, we need to plan along for those who are not part of the online classes, those who joined today. What we are going to do, we are going to communicate also in the group, but what is important is just to meet on certain basis so that we can revise question papers, whether you are part of the online classes, you are also supposed to join others, as we are just doing like question papers just for revision's sake. So because of today, we just started something, and without preparation, it was something that was just out of without a preparation of it. So I want us to prepare on it so that if we are to say we are going to take 4 hours or 5 hours or whatever number of hours as we are just revising towards our exams, it can be like that, but having specific days that we gonna meet. So tomorrow, I think it's best. Tomorrow I will just have to try tomorrow. Let us try to meet again. So I think 7 o'clock is gonna be also fine. If we can meet from 7 o'clock, at least we can extend our time from that 7 o'clock, at least we can extend our time further. So some of us, I don't know what part of the group, were asking about some other topics and so on. Yes, I understand on the issue of topics that we want to cover. I understand that. So can we send those areas so that we can consider them? I think that can be best. So we'll discuss. If I just have time, I will just send a message in the group so that we are supposed to respond in the major group so that we